topic is local maxima and local minima points. Local maxima or local minima. Before that, you must know what is maximum and what is minimum. Let us say this is the graph. If at any point function changes from increasing to decreasing or from decreasing to increasing, function changes at this particular point. If at this particular point, let us say point x naught, right? If function at this point is greater than equal to f of x, then your function is at this point is maximum. And let us say at this point fx naught will be less than fx. Fx naught will be less than fx, then your function is minimum at this particular point. Now what is local maxima and local minima is? See, at this point in the neighborhood function is maximum, at this point function is minimum, at this point also, at this point also, at this point also function is changing. So for a function we can have 2, 3, 4, 5 as many number of maximum values, means it is locally maximum. We are not comparing these two, that out of these two which one is maximum, we are not comparing that, right? So locally from increasing to decreasing, if function is going, this point is the point of local maxima, this point is the point of local minima. So we can have more than one local maximum values. Now we do have two tests for this to find out whether the point given. So first of all you have to find the critical values. So after that we have two methods to solve it, that whether point is of local maxima or point is of local minima. Look at this. First method is your first derivative method. First derivative test to check whether the point given is of local maxima or local minima. What you do is, the very first thing is find the derivative, put it equal to 0, you will get the critical values. ABC critical values you will get. Now suppose we are taking point A at x is equal to A, first point. We are taking a small value less than A, that is A minus h. H is of very small value, this is very important. As suppose the value of A is 3, you can take 2.999, you cannot take 2, right? So less than 3, it is 3 minus h, where h is of very small value. Then we need to consider A plus h, a small value greater than this, right? So at x is equal to A, x is equal to A minus h. This you have to put in the derivative. At this point you have to check whether it is coming positive or negative. Suppose we are taking that f dash x at A minus h is positive, and second at x is equal to A plus h, f dash x will be negative. So from positive to negative, it is the point of maxima. From positive to negative, point of maxima. Same at other point. at x is equal to b, at x is equal to c, at x is equal to d, number of points are there, same method, put x is equal to b minus h. Two very important things, sir. First thing is that h is, you have to consider always in your mind, as you are taking positive or negative, h will be of very small value, means you are considering x is equal to a minus h, like 3 minus h. So 3 minus less than 3 means 2.99, you cannot consider it 2. Okay. Second thing is, first you have to take, means you are going in this direction, first a minus h, then a plus h. So b minus h, your f dash x is, let us say, negative, and at b plus h, your f dash x will be positive. So from negative to positive, your function is locally minimum, and this is locally maximum. Positive to negative, locally maxima, negative to positive, locally minima. Right? Very rare cases we have, if sign does not change, positive to positive or negative to negative at any point, this is also positive, this is also positive, then that point is point of inflection. If function does not change its sign, that point is known as point of inflection. Now let's take one or two example on first derivative test. It will be more clear in that case. Just write it down.